Alright, so we're going to do a little example today dealing with limiting reagents. Alright, so we're going to look at a combustion reaction between ethane and oxygen. And remember, of course, oxygen is a Hunkelbrief element, so every time we talk about it, it's always going to be diatomic. So we'll just have to write out the balanced combustion reaction for this. So we have here 2 ethanes plus 7 oxygens give us 4 carbon dioxides and 6 waters. And just verify, yes, we have 4 carbons on both sides, 12 hydrogens, and 14 oxygens. So there's 14, and then we have another 8 plus 6, that's 14. So everything is nice and balanced for this one. And usually for these complicated combustion reactions, I'll just balance it out just to save you a little time. The first thing we'll need to do here is write out what our molecular weights are for everything. So, of course, just remember, carbon is, of course, 12, oxygen is 16, hydrogen is 1, so we can very easily just figure this stuff out. So for my C2H6, well, that's going to be 24 for my carbons plus another 6, so that's going to be 30 grams per mole. For oxygen, that's 16 times 2, so that's going to be 32 grams per mole. For my CO2, that's going to be 32 plus another 12, so that's going to be 44 grams per mole. And water, that's 16 plus 2, that's going to be 18 grams per mole. Then the next thing is find out, well, what information do we have in the problem here? So we have 10 grams of ethane plus 10 grams of oxygen. So this is going to be 10.000 grams of that. And our question is, how much CO2 and water are we actually going to make in this case? And in this case here, the amounts are not going to completely react with one another. There's one of them is in excess, the other one is going to be limiting, so we have to figure out, well, what is my limiting reagents in this case? So the way we do this is through stoichiometry, and basically go along and find out, well, which product is going to be produced less, and go with that. All right. Now we have here, of course, 2 products. I can use either one. I can choose carbon dioxide or water. Either way will give you the exact same answer, because all we're interested in at this point is figuring out, well, which is going to produce less of your product, right? So is the ethane going to produce less carbon dioxide, or is the oxygen going to produce less carbon dioxide? Or I could say the same thing with water. Either way, you'll get the same answer. So what we want to do here is then I'll just choose the carbon dioxide, because it's the first one, which, like I said, you could easily do this with water, is go here, and I'll just leave off the extra zeros here just for some simplicity. But we have here my 10 grams of my ethane, and then we're going to use our molecular weight to convert this into moles. And at this point, you need to use your mole ratio to figure out, well, there are 4 moles of carbon dioxide for every 2 moles of ethane. And this is why I always say, write down your units, because otherwise, like we talked about earlier, you wouldn't know exactly where to put, my CO2 or my ethane. So now we can see here, what's canceled out, right? The grams of my ethane cancel, my moles of my ethane cancel, and I'm left here with moles of CO2. Now you could multiply this at this point by the molecular weight of CO2, but really, if we just stop at this point, it saves you a little calculator time. So we can just figure out how many moles of CO2 this will actually produce. So once you go through the math, we get, so this will predict that, if all my 10 grams of ethane are reacted, we will get 0.666 moles of carbon dioxide to come out. And that would be, if all of this reacted. Now we'll do the same calculation, except we're going to be using oxygen instead. And in this case, now we have 4 moles of CO2 to 7 moles of oxygen. And when we do this calculation, we get, so of course the limiting one is the one that's going to produce less of the product, because it is of course limiting. So if you look right here, the oxygen produces a smaller amount of the carbon dioxide. So this means that my oxygen here is limiting, and then my ethane is in excess. Now at this point we want to figure out, well, how much carbon dioxide and water are going to be produced. And since we know here that the ethane is going to be in excess, we can also figure out how much of that ethane is actually going to remain at the end of this reaction. So first up, we can find out how much carbon dioxide is produced very easily. We already have the moles of carbon dioxide. And at this point, we just need to multiply this number here by my molecular weight, and we have our answer, okay? So that's going to give us... And then we can also figure out how much water is made. So since we know that we're going to be starting here with the 10 grams of oxygen, we just run through this. And now we're going to use 6 to 7 in this case. And then our 18 grams per mole. And you can very easily see grams cancel out, moles cancel out of oxygen, moles of water cancel, and we're left with grams of water. And this will give us, this is the grams of CO2 and water, and these are the amount produced. All right, so at this point, we need to figure out, well, how many grams of my ethane has actually been used up here, and then we can find out how many grams of ethane actually remain. And again, same kind of stoichiometry that we're going to be doing here. In this case, it's going to be 7 moles of oxygen to 2 moles of ethane. And that will give us, and remember, this is the amount of ethane that was actually used for the reaction. All right, and just as a good double check, we've used up here 10 grams of the oxygen because, of course, that was my limiting reagent, so all of this has been used. And we reacted here 2.679 grams of my ethane. So that means that if the total here for my grams of carbon dioxide and water that have been, the grams of my carbon dioxide and water that have been produced should be equal to 12.679. Now, there is a slight little discrepancy right here in the last decimal place. That's fine. It's just a simple rounding error that could have happened. So, these little small differences you don't worry about. If you're off by several grams, then you're like, whoops, I went through my calculations wrong there. And the other thing is we can also find out how much ethane actually remains. So, of course, this is the amount used. We started out with 10 grams, so it's just going to be initial minus the used. It's going to give me the amount remaining. So that's all of our important numbers. So you got this one here, this one, and that one. So, there is, a lot of numbers to kind of keep track of when we're dealing with this, but really, it's not so bad. You just, look at the equation, think about every single part of it, and, it's good. So just to recap, what we did was, of course, we started with our balanced equation. We started out with our molecular weights, always a good place to start with these. Then, of course, the info that was in the problem. And then we figured out what our limiting reagent was. We figured that the oxygen produces less of our product, so we went with this one. Then we just took that number of moles there, multiplied by our molecular weight. That gave us how many grams of CO2. Then we went here, again, using our 10 grams of oxygen to figure out how much water was produced. And then we used that 10 grams of oxygen to find out how much ethane was actually reacted here. And then finally, we just double checked our work to see that the amount of mass in our product over here was equal to the mass of the stuff that actually reacted. There's a small little discrepancy, but like I said, it's just a rounding error in the last decimal place, so that's you don't worry about. And then finally over here, we just found out how much of my ethane actually remains, and that's just, of course, since we know how much was actually used, we just subtract that off from the initial amount that we had. Again, when I give these little examples, work through them on your own, see if you get the same answers, and hopefully you will, and when test time comes around, this will be a lot easier. All right, so this should actually be a short video for once. Yay!